In this nugget, we'll be looking at the percentage yield of chemical reactions. Many of the materials and products you use every day, such as medicines, plastic, and ink, are made using chemical reactions. It's very important for manufacturers and scientists to make the right amount of each material in order to meet the demand. It's a little easier to think of making biscuits. If this is a recipe for 20 biscuits, how much of each ingredient would you need to make 40 biscuits? You can easily work out how much flour, eggs, butter, and milk you would need to produce double the number of biscuits, or even half the number of biscuits. It's exactly the same for chemical reactions, it's just not biscuits that we're making. Chemical A reacts with chemical B to make chemical C and chemical D. A and B are the reactants, and C and D are the products. Chemical C is the chemical that we want to make in the lab, and we want to make 50 grams of it. The amount of product made in a chemical reaction is called the yield, and when we calculate the mass of the product that we should get from a reaction, we call that the theoretical yield. So imagine that we calculated how much of A and B we needed to mix together in order to yield 50 grams of C, and we carried out our reaction. But the yield was only 40 grams. What could have happened? Remember that no atoms are created or destroyed during a reaction. So where has the mass gone? Some of chemical C could have been left behind in the equipment we used. Some of chemical C could have been lost when we separated it from chemical D. An unexpected and unwanted reaction could have happened. The reactants may not have been pure, and perhaps the reaction is reversible. A reversible reaction means that the products also react together to reform the reactants. We use a different arrow to show a reversible reaction. If we made 40 grams of chemical C when we were expecting 50 grams, what was the percentage yield? Percentage yield tells us how much product we actually made compared to the amount of product we calculated we would make. To work out percentage yield, we need to divide the actual yield by the theoretical yield and then multiply by 100. For our example, the actual yield was 40 grams, when we calculated that we would get 50 grams. 40 divided by 50 is 0.8. 0.8 times 100 is 80. So the percentage yield of this reaction is 80%. Let's do another example. The theoretical yield for a reaction to manufacture the painkiller paracetamol is 127 grams. However, only 83.82 grams was produced. Calculate the percentage yield of paracetamol in this reaction. So our equation is percentage yield equals actual yield divided by theoretical yield times 100. The actual yield was 83.82 grams. When we calculated, our theoretical yield would be 127. So the percentage yield is 0.66 times 100. So our answer is 66%. The percentage yield of paracetamol in this reaction is 66%. To summarise, a chemical equation shows us the reactants and the products of a reaction. Mass is not created or destroyed in a reaction. We call this conservation of mass. The amount of product made in a reaction is called the yield, and we can predict the yield. This prediction is called the theoretical yield. In reality, the yield is slightly less than the theoretical yield. The percentage yield tells us how much product we actually made compared to the amount of product we calculated would be made. Keywords. Chemical equation shows the reactants and products of a reaction. Reactants, the starting substances in a chemical reaction. Products, the substances formed in a chemical reaction. Yield, the amount of product made. Reversible reaction, a reaction where the products can react together to reform the reactants.